So in this video, we are going to discuss about inverse discrete Fourier transform. So the first question is perform the 4-point IDFT for the following value x of k is equal to 20 minus 4i, 12, 4i. So this is our previous problem, right? So before watching this video, please see the description box. So you can refer the 4-point DFT, how to perform the 4-point DFT. So here you can see this is a that circle and the value, this is a unit circle and their value is 1 minus 1 j and minus j. Okay, and you know the formula for IDFT, right? So you note down that formula. So in order to find the value of x of n, okay, so x of n formula is 1 divided by n into summation n is equal to 0 to n minus 1 x of k e power j 2 pi k n divided by n. So here minus is missing, right? So what you have to do, first for to find the x of 0, you have to substitute 1 1 1 1 1, right? Next, instead of going like clockwise direction, you have to go in the anti-clockwise direction. So you have to write 1 j minus 1 and minus j, 1 j minus 1 and minus j. So in order to find the value of x of 2, right, x of 2, so you have to leave the 1 point. So if I leave 1 point, you will get 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1. Next you have to leave the 2 points. So 1 minus j, right? So again, if you leave these 2 points, you will get minus 1. Again, if you leave these 2 points, you will get j. So 1 minus 1, minus j, minus 1 and j. Okay. So in order to find the value of x of 0, so if I want to find the x of 0, you have to divide the answer by 4. Okay. So let us now. So first, in order to get this value, so if a value of x of 0, small x of 0, so you have to add this value. So if we add this value, we get answer as 32 and they have to divide it by 4. Okay, so in order to get x of 0. Okay, so x of 0 value is 32 divided by 4 is 8. Okay, so there's my previous answer, right? So similar way, you have to multiply 1 j minus 1 and minus j. So if you multiply this one, okay, you check the answer, right? So this is nothing but 8 and this is j square and this is also j square. So it will get cancelled out, right? So first x of 0 is so in this problem you see, so you have to multiply j and minus j. So what is j square? J square is minus 1, so you will get 4 and here also you will get 4. So it becomes 8. So you will get the answer as 16 divided by 4. That is answer is 4. So here if you solve this value, you will get answer as 32 divided by 4. That is nothing but 8. X of 3 is equal to 0 because these two get cancelled out. Okay. So now let us come to this problem. Okay. So here they have given x of k is equal to 4, 0, 0. Okay. So what is x of 0? X of 0 is addition of this value divided by 4. So answer is 1. Right. What is x of 1? X of 1 is equal to 4 into 1, right, plus 0 into j plus 0 into minus 1, right, plus 0 into minus j. Okay, so we will get answer as 4. Next, 4 divided by 4, that is 1, right? So x of 2. So what is x of 2? 4 into 1 plus 0 into minus 1 plus 0 into 1 plus 0 into minus 1. So you will get 4. So is your answer. If you divide it by 4, you will get answer as 1. Next, x of t also, you will get 4 divided by 4, that is nothing but 1. So my x of n values is equal to 1, 1, 1, 1. Okay. So this is the step for IDFT, inverse discrete Fourier transform. So you can verify this. Okay, x of n is equal to 4 ones. In similar way, if x of k is equal to 1, 1, 1, 1. Okay, what is x of 0? X of 0 is equal to addition of this value divided by 4, that is equal to 1, right? X of 1 is equal to 1 plus j minus 1 minus j. So you will get answer as 0. What is x of 2? X of 2 is equal to 1 minus 1 plus 1 minus 1. That is equal to 0. What is x of 3? X of 3 is equal to 1 minus j minus 1 plus j. So you will get answer as 0. Okay. So what is x of n? X of n is equal to 1, 0, 0, 0. So this is nothing but this is all about your IDFT, inverse discrete Fourier transform. Okay. So next we can go for how to perform the 4-point DFT using DIT algorithm. For the following values, x of n is equal to 8480. So the DIT algorithm comes under FFT. Okay, so the FFT is having two types of algorithm. FFT means fast Fourier transform. One is DIT, discrete decimation in time. Another one is DIF, decimation in frequency. Okay. So here also I have two ways to solve this problem. Okay. So here also you have 4-point FFT and 8-point FFT. Okay. So they are telling it as butterfly diagram. In short. So let us discuss this butterfly diagram in the next class. Thank you.